Polygons and their angle measures. What is a polygon? A closed figure formed by a finite number of coplanar segments so that each segment intersects exactly two others, but only at their endpoints. So here are the classification of polygons and not polygons. Here you have line segments, their closed figure has vertex, that's polygon. We call them vertices actually. But not polygon is a curve or a circle, or if they cross like that, overlap, and if it's unclosed, those are not polygon. So polygon has to be a closed figure and has to have line segment. So classifying a polygon, there are two types of polygon, convex. Convex polygon is no line containing a side of polygon contains a point in its interior. So everything is closed like this, and then there is, no line containing a side that contains a point in its interior. So there's it's not going. But concave is like concaved in, like this. So a polygon for which there is a line containing the side of the polygon and a point in the interior of a polygon. So when x actually goes in like this, so the angle of each angle in the polygon for convex polygon is less than 180. But if you look at this concaved in polygon, this angle is more than 180. That's called concaved polygon. So this is convex. When you guys see a polygon goes in and the interior angle is more than 180, that's called concave polygon. So this is convex and this is concave. There are two types. So classifying polygon, there are three types. You have equilateral polygon. So please write that and write all sides are congruent. So if every single side is congruent like this, that's called equilateral, even though the angles look different. We'll talk about the size. Now, if you have all interior angles are congruent, like squares and rectangle, that's equiangular. So E-Q-U-I, angular. So equilateral, the lateral means size. Equiangular means equal angle. So if they're all interior angles are congruent, that's equiangular. And then just a regular polygon means they're equilateral and equiangular. So if they have equal size, equal angle, we call that actually regular polygon. So there are three types: equilateral, all sides are congruent; equiangular, which is all angles are equiangular; and then regular polygon means both equilateral and equiangular polygon. So they have same size and same congruent angles inside. Irregular polygons are two sides or two interior angles are not congruent. So if you have two sides that are not congruent, if you have two interior angles are not congruent, okay, that's irregular polygon. So irregular, they're not congruent. So these three are not irregular. So anything besides these three, when they're not congruent, we call that irregular polygon. So naming polygon, we need to know that 3 triangle, 4 quadrilateral. The word tri is 3, quad is 4. 5-sided polygon, that's pentagon. 6 is hexagon. 7 is heptagon. 8 is octagon. 9 is nonagon. 10 is decagon, like decade, like 10. 12 is dodecagon. And anything after 12, we're going to say 13gon, 14gon, 15gon, 20gon. We don't have names after 12. We don't have 11 side. That's just 11 gon. So right here, the gon means angle. Okay? So you need to know the names for these, okay? But anything after 12, we just put the number and put dash gon. So like 11 dash gon, 13 dash gon, 20 dash gon. We don't have names for them after 12. So there are some formulas that we need to know for convex polygons. If you want to find the number of diagonals in each polygon that can be drawn from one vertex, you can use n-3. This is the formula for that. This is a formula for number of diagonals. N represents number of sides. So if you have a triangle, 3, plug in 3, n is the number of sides, so plus 3 minus 3, 0. There's no diagonal here. But if I do quadrilateral, put 4 into n minus 3, there's a 1 diagonal. And then if I have a pentagon, 5 minus 3, which is 2, so you can draw 2 diagonals from one vertex. So this is the formula for number of diagonals. And then there's another formula for number of triangles that can be created from one vertex. If you put the n minus 2 is the formula. So if I do 3 minus 2, that's one triangle. If I do 4, which is quadrilateral, this is the number of sides, minus 2 is 2 triangles. And if I do 5 minus 2, which is pentagon, that's 1, 2, 3 triangles, as you can see in my drawing. So this is a formula for number of triangles inside each polygon. So another formula we need to know is the sum of the measures of the interior angles. So if you have in the measures, here number of sides, so this is 3 minus 2, which is 1. 1 times 180 is 180. That means if I add 3 angles in a triangle, it's 180. And if I put 4 minus 2 is, this is the number of sides. For quadrilateral, 4 minus 2 is 2. 2 times 180 is 360. That means if I add these 4 angles, that's 360. So it gives you sum of all the angles inside. And this is the formula, n minus 2 times 180. And it works for pentagon, it works for any gon that you have, polygon. So you do 5 minus 2, which is 3 times 180, like that. So that's the formula. And then sum of the measures of exterior angles is 360. So we need to know that. So when I add all the exterior angles, that is 360. Okay, so keep that in mind. So regular polygon formulas, measure of each interior angle is n minus 2 times 180 divided by n. That is the formula for regular polygon, which is equilateral, equiangular. So measure each of the, if you want to measure each of the interior angle, you do number of sides minus 2 times 180 divided by n. So if I have a triangle, right, and it's equilateral, equiangular triangle, then I'm going to put 3 into n. So 3 minus 2 is 1. 1 times 180 is 180 divided by 3. That means each angle is 60. So this gives you measure of each angle. But it only works for regular. The regular means equilateral, equiangular. They're all congruent. Congruent sides, congruent angles. So it works for any polygon as long as they are all congruent sides and congruent angles. So you can use it for quadrilateral, which is a square. You can use a square. So 4 minus 2 is 2. 2 times 180, and that's 360 divided by 4, that's 90. So each angle is 90 degrees for a square. So this is the formula for that. Another formula is measure of each exterior angle for regular polygon. You just do 360 divided by number of sides. So outside for each one, if I have a triangle, I do 360 divided by 3, which is 120. So outside is like this, like here, right? So outside will be 360 divided by 3, which is 120 for each exterior angle, which makes sense because outside, if you draw a line, inside will be 60 plus 120. If I draw a line outside, it's going to be 180, right? So for triangle, any polygon, if they're regular, you do 360 divided by n, then you're going to get each measure angle for exterior. So like these. The exterior angles are these. So you get the each measure. Because the sum, when I add 1 plus 2 plus 3 plus 4 plus 5, is 360. But if I want to do each, I do 360 divided by this one has a 5. So 5. But it only works for regular polygon. Okay, all congruent polygon. So why don't we do the sum practice? What is the sum of the interior angle with an 11 gon? So here we're going to use this formula. You're going to write the formula. N minus 2 times 180. That is the formula. So 11 minus 2 is 9. 9 times 180 is 1620. Use calculator for that. This is the sum of all the interior angles inside of 11 gon. What is the measure of an exterior angle of a regular polygon? Then you do 360 divided by n. Octagon is 8, so 360 divided by 8, 45. So the measure of exterior, outside, is 45. So you use formula for that. Let's do another practice. What is the number of sides of a regular polygon with exterior angle 72? So you're going to write 72 equals 360 over n. You're going to find the number of sides this time. It only works for regular polygon because 360 is the sum of outside. So you're going to multiply each side by n. So 12, cross multiply. So 72n equals 360 divided by 72. N equals 5. So you get 5. That's pentagon. So pentagon has exterior angles of 72. Let's do another one. What is the measure of an interior angle of a regular polygon with 30 sides? So first, you're going to see, underline this, interior angle is 5 times the measure of the exterior. So that means 5x plus x equals 180, right? Because one interior, one exterior, that equals 180. Then 6x equals 180, x is 30. So 30 is the exterior. Then x equals 30. Then you do 360 divided by whatever the number of sides equals 30. Then n equals 12 because if I divide 360 divided by 30, I get 12. So it's actually dodecagon. Let's do another one. Find angle Q and angle R right here. So first, you're going to look at, you're going to use n minus 2 times 180, which is the formula. So when you do this, you have to use the formula and look at the notes and see what applies. So you're going to do sum of the measure of interior angles. You have, we're looking for x and 2x, but you have 70 and 180. I mean, it's 70 and 80. So you're going to use the formula for sum of the measure of interior angles right here inside. That's n minus 2 equals times 180. As you can see, you have 1, 2, 3, 4 sides. This is trapezoid quadrilateral. So you do 4 minus 2, which is 2. 2 times 180 is 360. So 360, and you don't need to do this actually. You know that a quadrilateral has 360 inside. So 360 equals 70 plus 80 is 150. And then x plus 2x is 3x. Solve for x and plug it in. Subtract 150, which is, and then divided by 3, x equals 70. So when you add 70, 140, 70, 80, you get 360. So for number of sides, you need to use this formula. And this one is maybe, because it's 360, you don't have to use that. But for other polygons, you need to use that. So please notice that when you're actually finding the sum of the interior angles, here we start with 180, and if you just keep adding 180 to each one, that gives you the sum of the interior angles. So 180, another 180 is 360, another 180 is 540, another 180 is 720, which is the sum of the hexagon. That is where the formula is coming from, because each polygon has 1, 2, 3 triangles. So you just multiply everything by 180 times 2, 180 times 3, because if you look at this, there's a 1 triangle, 180, quadrilateral has 2 triangle, pentagon has 3 triangles, so that's what we're doing. Please do the homework sheet that I attached to your notes after this, and please use your notes, and then we're going to check in class. So please use the formulas that we just saw, and I want you to finish your homework, okay? So please do the worksheet now. Thank you.